Hi, this is Electronics with Mr. Estabrooks, and the last topic we need to discuss in this unit is Kirchhoffs Current Law. Now, hopefully you'll remember that Kirchhoffs voltage law applies to series circuits. Kirchhoffs current law applies to parallel circuits. So here we have a parallel circuit, 3 loops, 3 branches. The resistors in each branch or each loop are different. And we're going to need to find basically the current in each branch, the total resistance, and the total current flowing through all branches. Now basically, Kirchhoff's current law states that the amount of current coming into a branch, again, if we think of this, here's the negative end of our battery. If we think of this as a faucet, turn on the faucet and electrons come out and they flow this way. The amount of current entering a branch equals the sum of the amount of current flowing through the other 2 branches. So this current here, whatever that is equal to this current plus this current. And the same thing here. We have this much current here flows, and then some of it goes here and some of it goes here. This much current here is equal to this current plus this current. Then when it comes back around, of course, these 2 come together and they have to add up to the amount of current flowing here. And back again until we get around to the positive side of the battery. Okay, so what we need to calculate for this circuit, first of all, total resistance, total current, and the current flowing through each branch, each loop, each resistor. So you remember the total resistance is that funky reciprocal formula because it's a parallel circuit. 1 over the reciprocal of R1 plus the reciprocal of R2 plus the reciprocal of R3. Whoops, 1 over R3. Now if you do the math, plug in the numbers, RT equals 1 over 1,000 plus 1 over 2,000 plus 1 over 3,000. And if I did my math right, I come up with 545 point something ohms. Now we can get the total current, IT. Now let's write this in here, 545 ohms. We can get the total current by applying Ohm's law. We have total voltage, we have total resistance, therefore Ohm's law states that current equals volts divided by ohms, which is going to be 12 volts divided by 545 ohms, which comes out to be, I think, 22 milliamps. 0.022 amps equals 22 milliamps. Put it in proper SI notation. Now, these 3 are actually fairly easy to calculate also using Ohm's law. If you recognize, here I'm going to take my probes here, right? Here's the positive end of the battery here, right? Well, if I measure the voltage from here to here, clearly across the battery is 12 volts. But look, this is just a wire all the way over to here. So no matter where I put my, again, if I put my positive probe here, or I put my positive probe here, or here, or here, the voltage from here across to the negative side of the battery, from here to here, or from here to here, from here to here, it's 12 volts. So basically, in parallel, as you should know, the voltage across each loop is 12. So the voltage drop across each of these resistors is 12 volts. Well, we can use that to calculate the current because we know that VR1 equals VR2 equals VR3 equals VT equals 12. Voltage is the same across every loop. Well, if that's the case, then we know that, again, Ohm's law, current equals volts divided by resistance. So VR1 is 12 equals 12 volts divided by 1,000 ohms equals 0.012 amps, or 12 milliamps. You can do the same for R2 and R3. IR2 equals 12 volts divided by 2,000 ohms. Of course, since 2,000 is twice 1,000, it's going to be half of this, 0.006 amps equals 6 milliamps. And then R3, IR3 equals 12 volts over 3,000 ohms, which should be 3 times the first one. The R3 is 3 times R1, so the current is going to be a third of that, or 0.004 amps. Now here's where Kirchhoffs current law comes in as a discount double check, right? If we add up each of the currents in each loop, IR1 plus IR2 plus IR3 should equal my total current. 12 plus 6 plus 4 equals, oh, look at that. How nice, 22 milliamps. And that's what we calculated up here. So 12 milliamps, 6 milliamps, 4 milliamps, and our check, we're back to 22 milliamps. So again, it's useful when you have multiple ways of calculating things because you can check your answers.